So, what if I told you that some of the most rugged, youngest looking landscapes on our planet are actually ancient? I mean, places that look like they were carved just yesterday, but are in reality older than the dinosaurs. It's a fascinating geological illusion, so let's dive right in.
First things first, let me ask you something. When you picture an old landscape, what pops into your head? For most of us, right, it's probably something kind of gentle. Rolling hills, maybe a mountain that's been worn down to a smooth nub after eons of wind and rain.
Well, here's where it gets interesting. Our intuition is, more often than not, completely wrong. We automatically think old equals worn and smooth. But in geological reality, a landscape with jagged, sharp peaks like you see on Baffin Island, that rock is over 2.5 times billion years old. It's a huge reminder that our human sense of aging just doesn't apply to the Earth.
What we're really dealing with here is this grand geological illusion. It's a trick of time, climate, and chemistry that completely messes with how we perceive the world. And this, right here, is the key takeaway for this whole explainer. The sharpness of a mountain peak or the smoothness of a plain, it's actually a terrible way to guess its true geological age. You see, the Earth just plays by a whole different set of rules.
So the big question is, how does an ancient landscape manage to keep this youthful look for millions, or in some cases, billions of years? Well, it turns out there's a pretty specific recipe for it, a combination of special ingredients that can basically hit the pause button on the aging process. Okay, so this recipe has three main ingredients. First, you start with the bedrock itself. It has to be incredibly tough stuff. Think geologic granite, something that just defies wear and tear. Second, you need a climate that acts like a natural preservative. We're talking extreme conditions, like a bone-dry desert or a permanent deep freeze, where the usual forces of weathering just stop. And finally, and this is the most counterintuitive part, sometimes the very process of erosion, which we assume smooths everything out, can actually work to make things sharper.
All right, let's go see how this recipe actually plays out in the real world. We're going to look at a few incredible examples of landscapes that are, for all intents and purposes, locked in time.
Our first stop takes us to the Kaukovold Plateau in Namibia. I mean, look at it. Those sharp cliffs and deep canyons just scream youthful and dynamic. But there's a reason the source material calls this place the mummified desert.
And that reason is pretty staggering. The bedrock that makes up this rugged terrain is over 1.2 billion years old. Now, to put that into perspective for you, that is older than the very first complex multicellular animals on this planet. Just think about that.
So, what's the secret sauce here? Well, it's that hyper-arid climate. It has literally mummified the landscape. With almost no water, the chemical weathering that would normally round off all those sharp edges has basically ground to a halt. It preserves the ancient shapes made by tectonic forces, almost like a piece in a museum. What you're seeing isn't a new structure, it's an ancient one, kept perfectly pristine by the desert.
Okay, so from the extreme heat of the desert, we're going to jump to the extreme cold of Antarctica. We're going to a place called the McMurdo Dry Valleys, which you could call a frozen relic.
These valleys, they're some of the oldest continuously ice-free surfaces anywhere on Earth. I'm talking about surfaces that haven't seen any significant change in as long as 14 million years. It's wild.
And this is a perfect example of that deep freeze principle we talked about. The climate here is so intensely cold and so dry that it shuts down almost all erosion. You can still see ancient river channels that were carved millions of years ago. The landscape isn't young, it's just literally frozen in a state of almost perfect stillness.
And for our last case study, we've got the most mind-bending example of them all, the Tsingy de Bemaraha in Madagascar. This is a landscape that is, somehow, unbelievably, sharpened by rain.
This incredible maze of limestone blades, it looks like something straight out of a fantasy novel. It started forming over 200 million years ago. That's before the earliest dinosaurs even walked the Earth.
So, how in the world does rain make rock sharper? It's all thanks to a process called karst erosion, which is unique to limestone. See, rainwater is naturally a little bit acidic. It seeps into these vertical cracks in the rock and dissolves it straight down. So instead of sanding down the tops, it just carves the grooves deeper and deeper, making the spires taller and sharper over millions and millions of years. It's erosion working in the complete opposite way we'd expect.
So what's the big lesson in all of this? Well, these landscapes, they really force us to adjust how we see the world.
to learn to see in what geologists call deep time.
Just to try and grasp the scale here, take a look at this timeline. The McDonald Ranges in Australia, another one of these ancient yet young-looking places, they formed 400 million years ago. Dinosaurs didn't even show up until 200 million years after that. And the entire history of human civilization? It's just that tiny 5,000-year sliver at the very, very end. The timescales are just almost impossible to comprehend.
And this really is the heart of it all. As the source material puts it so perfectly, these landscapes teach a profound lesson. The Earth's rhythms operate on scales far beyond human perception. Our intuition is built on a human lifespan, but the planet is operating on a completely different clock. So we're left with this final thought to chew on. The Earth is holding all of these incredible stories, written in the silent language of rock and climate and immense spans of time. And the real question is, are we patient enough to learn how to read it?